Good morning, one and all present here. It is my pleasure to welcome you all for the seminar MapReduce in Hadoop. Already we discussed many topics in big data analytics, which includes Hadoop oriented information. The Hadoop oriented information like NoSQL, NoSQL databases, Hive, and the introduction about the Hadoop, everything we discussed. Now we discuss about what is the use of the Hadoop. Which includes the MapReduce method. What is the use of the MapReduce method? Just a minute. Okay. In this webinar, we have to discuss a little bit about how to use and what is the use of the MapReduce in Hadoop. What are the terminology available in order to utilize the MapReduce functions which are available in Hadoop, and what concepts we can able to utilize the MapReduce methods in Hadoop are to be discussed in this webinar. What is the agenda of this webinar? First, we have to discuss the definition of Hadoop and the definition of MapReduce. Then what is the requirement of MapReduce? Why we require MapReduce? What are the algorithms available for MapReduce method? What is the terminology utilized in MapReduce? How we can execute the MapReduce programs in the Hadoop environment? Finally, we discuss some examples with the illustration. Then the final agenda of this webinar is to discuss about the summary of the MapReduce method. Okay. Nowadays, the technology growth is very important. The technology is rapidly changing the way of data which is produced and processed, analyzed and consumed in the real world applications. For the real world applications, there are a large volumes of data are growing every second, every minute, every millisecond, every microsecond. What is the ultimate use of all the data which are produced by means of various kinds of data warehouse producers and data warehouse servers, which contains information about the real world applications? These are the nowadays the very famous topic which are available under the big data analytics. Why these are called as big data analytics, which are under the big data analytics means large volumes of data, all the data are perfectly utilized by the peoples. But the large volumes of data, how we can able to utilize? What is the ultimate use of the large volumes of data, huge volumes of data? For that purpose, we use the recent technology. The technology is big data technology. In big data, how we can able to utilize, process the data by means of some special kind of technology based processing method, which is called as big data analytics, in which Hadoop is the number one platform which used exactly for the processing purpose of the big data. Therefore, technology helps evolve new and more effective data sources. All these data sources are effectively utilized by various peoples, various users, different kinds of users. They are utilizing the available data in the internet as well as in different database, data warehouse, data mart repositories for their purpose alone. On the other hand, more and more data gets captured every day, every second, every minute. Technology steps into help process this data quickly, efficiently, and how to visualize it to drive informed decisions. This is the requirement of the technology growth. For the processing purpose of the recent technology, the number one software which is utilized by many peoples nowadays in the world is Hadoop software. It is 100% open source framework. It is 100% open source software, not proprietary software, which is non-proprietary software. The Hadoop is used to store and process big data in a distributed environment, also in the parallel environment. The Hadoop software, the Hadoop framework contains two modules. One is MapReduce and another one is HDFS, Hadoop Distributed File System. There are exactly two components available in Hadoop software. What is the use of the Hadoop? In order to process the big data, in order to utilize properly the big data, large volumes of data, the Hadoop is exactly utilized, in which there are two modules, there are two components, there are two main areas. One is MapReduce and another one is HDFS. What is the use of this MapReduce and HDFS? The MapReduce is a parallel programming model for processing large amounts of structured, semi-structured, unstructured data on large clusters of commodity hardwares. Large commodity of informations oriented database repositories are available in the real world applications, which are semi-structured, unstructured, and structured. How we can able to process these large amounts of data in a parallel manner, which is done by the MapReduce method. In a parallel method, parallel processing concept, parallel programming model, the MapReduce works. Then what is the use of the HDFS? HDFS is a part of Hadoop framework, which is used to store and process data sets, which provides a fault-tolerant file system to run on commodity hardware, which gives some fault-tolerant file, mostly in the Hadoop. MapReduce is the first phase and the HDFS is the second phase of the Hadoop environment. First, initially the MapReduce operations are carried out. Then the HDFS operations are done in Hadoop. What is this Apache Hadoop ecosystem? You see there, first, the entire ecosystem is Hadoop oriented ecosystem, Hadoop environment, Hadoop based processing. Here, the management and monitoring the Hadoop ecosystem is actually maintained by Ampari. This is one of the software management monitoring of the Hadoop oriented system. The software used for that purpose alone is Ampari. And then for the coordination purpose between MapReduce and HDFS and other kind of big Magnet and Hive softwares is done by Zookeeper, and the workflow and scheduling is done by OZ. For the intermediator between the MapReduce and other kind of softwares for scripting and machine learning and querying, the intermediator between this first one and this MapReduce is done by HBase, Hadoop base. Mostly in HBase, NoSQL databases are exactly utilized. Combining this HDFS and HBase, the data integration is perfectly done by using some softwares, Scoops, REST, and ODBC. This is the special kind of Hadoop ecosystem, in which what is the use of this MapReduce? The MapReduce is perfectly utilized for the purpose of distributing the distributed processing oriented information extraction. What are the components of Hadoop ecosystem? First one is HDFS, second YARN. HDFS means Hadoop Distributed File System. YARN, abbreviated from Yet Another Resource Negotiator. MapReduce is a programming based data processing work. And Spark is one of the software, one of the tool which is used to store the memory. How we can effectively utilize the memory. In-memory data processing work is carried out by Spark. Pig and Hive are activated based on the query-based processing of data services. HBase is NoSQL database. Mohat, Spark, machine learning library. These are some algorithms which is based on the machine learning softwares. Solar, Lucene, these are used for searching and indexing purpose of the Hadoop ecosystem. Zookeeper is utilized for the purpose of managing clusters. OZ is used for the scheduling of the jobs in between MapReduce phase and the HDFS phase. Okay, these are some simple components which are effectively utilized in the Hadoop ecosystem. Now, what is this? Hadoop architecture have two types, two modules. One is MapReduce and the HDFS layer. There are two layers in the Hadoop architecture, as already told. MapReduce layer and HDFS layer. In MapReduce layer, there are two kind of nodes are available. One is master node and another one is slave node. In the master node, job tracker and task tracker are available. What is the work of the job tracker and the task tracker? Job tracker assigns some jobs to the task tracker. The task tracker executes the command which is produced by the job tracker. This is the main work carried out in MapReduce layer. MapReduce layer having two nodes, one is master node and another one is slave node. In slave node, there are many slaves are available. Okay, master slave flip-flop, how a master slave flip-flop act. Like the master node and the slave nodes are exactly processed. In master node, there are two tasks. One is job tracker and another one is task tracker. The job tracker having some processing commands, which are the job tracker instructs some commands to the task tracker. The task tracker done the command which is produced by the job tracker. There are many tasks are available in a single layer, but only one job tracker is available in the master node. Like in the now the MapReduce layer, whatever which is produced, which is given to the input of the output of the MapReduce layer is the input of the HDFS layer. In HDFS layer, there are two kind of nodes. One is name node and another one is data node. Name node, as per the instruction given by in the MapReduce layer, the name node is the command producer, data node is the job processor. Job processor is the data node, command producer is the name node. The name node produces some commands and the data node done it, whatever the commands produced by the name node. Only one name nodes are available. There are many data nodes are available in the HDFS layer. We can use either MapReduce layer or we can straight away use the HDFS layer in some kind of execution control in the Hadoop architecture. Now we discuss about the detailed discussion about the MapReduce. So Hadoop MapReduce is a software framework for distributed processing of large data sets on computing clusters. It is a sub-project of Hadoop, Apache Hadoop project. Apache Hadoop is an open source framework that allows to store and process big data in a distributed environment across clusters of computers using simple programming models. Some simple programming models are actually executed by this Hadoop project, Apache Hadoop project. MapReduce, in which MapReduce is the one of the core component for data processing in Hadoop framework. MapReduce is one of the core component in the Hadoop framework. What is the definition of MapReduce now? MapReduce is a processing technique and a program model. It having a program model which are used for distributed computing based on Java. Before going to read out some points in MapReduce, how to utilize MapReduce, how to effectively use the MapReduce methods, you must have some idea about the Java language. Then only it is possible to understand the MapReduce method. If you have idea about the Java language, then only it is possible to understand the this MapReduce method. The MapReduce algorithm contains two important tasks. One is mapper and another one is reducer, which is also called as map and reduce. There are two components, important tasks available in MapReduce method model. One is mapper and another one is reducer. That is namely called as map and reduce task. Important two tasks. The map task is a set of data. Map task takes a set of data and converts it into another set of data, where individual elements are broken down into tuples. The tuples are then created by the MapReduce method mapper based on the key value and pair values, key pairs and key value pairs oriented information. So the map takes a set of data and converts it into another set of data, where individual elements are broken down into tuples. The tuples are produced by means of this map task. Secondly, the reduce task, which takes the output of the map task as an input. The reduce task gets input, which is produce a output from map task, and combines those data tuples into a smaller set of tuples. Therefore, the output of the map task is the input of the reducer task. The output of the map task is the tuples. The tuples are the input of the reducer task. The tuples are converted into smaller set of tuples in reducer task. This work is actually carried out in MapReduce method. Why we require the MapReduce? We want to assume a large amount of data, text data, large amount of text set data, which is stored in a single server. Is it possible to effectively utilize or download the single server oriented information at a time very quickly? Is it possible to download the information which are available in single server very quickly? Possible to quickly download the server informations? Definitely not possible. Which is centralized system. A centralized system contains a single server contains some informations which are based on the relational databases. Based on the relational databases, a centralized system oriented, server oriented informations are not easy to process quickly. So in order to quickly process the information which is available in a single server or also in the multi-server, we can require this MapReduce method. We can fetch information from multiple servers and get it easily by means of this MapReduce method. This is the main task actually done by MapReduce method. multi-server oriented informations are exactly fetched into for the processing of the big data. For the processing purpose of the Hadoop, the multiple server oriented informations are easily downloaded, easily processed. Suppose if you want to process the relational database, that is the traditional enterprise system normally have a centralized server to store and process data. The traditional model is certainly not suitable to process huge volumes of scalable data. As already I told you, the huge volumes of data is not easy to access by means of storing your information by using the traditional model, like relational database oriented traditional model, and cannot be accommodated by standard database servers. It cannot be accommodated using a standard database servers. So for that purpose, we require a specialized kind of technology in the processing method, that is actually the MapReduce method. Moreover, the centralized system creates too much of a bottleneck while processing multiple files simultaneously. While processing, while fetching, while downloading a multiple files from a single server, we have a bottleneck. We have some kind of threads, some kind of processing inefficiency. So in order to avoid the inefficiency of the multiple files downloading, processing, by using the relational databases, by using the traditional approaches, we require a special kind of approach, which is actually MapReduce in Hadoop. Okay, so in order to solve the above said problem, the bottleneck problem, Google solved this bottleneck issue using an algorithm called MapReduce algorithm. So MapReduce divides a task into smaller parts and assigns them to many computers. Usually we are all done the processing of a relational database management system by using a single computer. But if we use the MapReduce method, we can utilize many computers simultaneously in order to process your large volumes of data. This is called as distributed computing. This is called as parallel processing method. So distributed manner, how we can able to process your large volumes of data. The large volumes of data are splitted into small parts and give it to many computers. Each and every computer process the small part of a clustered data which is produced by the MapReduce method. This is actually done. The results are collected at one place after the processing of the multiple sources, and the results are integrated to form the result data set. This is actually done by using this MapReduce method. User requested the standalone server, the centralized system, in order to capture some information from different software, different hardware oriented, different computers, different servers. In order to capture some different servers, different computers, utilizing this different kind of information by means of this user is actually carried out by using this MapReduce method. Therefore, we can run multiple computers by utilizing this MapReduce method in order to do a multiple task, in order to process the large volumes of data by means of this MapReduce method. That's why we require this MapReduce method. What is the algorithm which is used for the MapReduce method? Which is a paradigm. MapReduce paradigm is based on sending the computer to where the data resides. Sending the computer to where the data resides. Wherever the data is resides, stored, we can send a request to the computer, from the computer to the computer. Then MapReduce program executes in 3 stages actually: map stage, shuffle stage, and reduce stage. The map stage, what is the map stage? The map or mapper or mapper task, mapper's job, which is used to process the input data. Generally, the input data is the form of a file or directory and is stored in the Hadoop file system, HDFS oriented system. The input file is passed to the mapper function line by line. The input file is passed to the mapper function one line at a time. So line by line execution is done by the mapper. The mapper processes the data and creates several small chunks of data, several small pieces of data. A single line is splitted into several pieces, several chunks by means of this mapper function, then which gives the input to the reducer stage. The reducer stage itself contains the shuffle stage. The reducer stage itself contains the shuffle stage. This stage is combination of shuffle stage and a reducer stage. The reducer's job is to process the data that comes from the mapper, which is actually derived from the mapper. The output of the mapper is the input of the reducer. Then it should be processed. After processing it, the output of the mapper is processed. After the processing, the input of the reducer produces a new set of output which will be stored in the HDFS system. The reducer produces a new set of output which will be stored in the HDFS system is the main task, main algorithm step of this algorithm. Actually, you got to understand input data. This is input data. See the figure here. Input data. There are many mappers are available. There are many reducers are available, but the mapper is larger than the reducer. The reducer is lesser than the mapper. Okay, so this is the main concept. Then the mapper gets input from the HDFS stored information files and produces output which goes to the reducer task. Reducer produces output and stores into HDFS file system once again. This is the main task. So during a MapReduce job, what will happen? Hadoop sends the map and the reducer task to the appropriate server in the cluster. The Hadoop actually sends a request to map and the reducer. The framework manages all the details of the data passing, such as issuing task, verifying task completion, and copying the data around the cluster between the nodes. Everything is stored, manages. The framework, the mapper and the reducer framework manages all these tasks. Most of the computing takes place on the nodes with the data on local disk that reduces the network traffic. Why the local informations alone are produced means for the speedy processing of the data. So local disk only it should be stored. Whatever the information which are produced by both the mapper and the reducer are stored in the local disk. After completion of the given task, the cluster collects and reduces the data to form an appropriate result and sends it back to the Hadoop server This is the small kind of work done by this map and reducer task. How this MapReduce works? This algorithm contains two important tasks. Already I told map and reducer. The map task takes a set of data and converts it into another set of data where the individual elements are broken. Already we discussed it. Key value pairs oriented. The output of the map is the key value pairs. The input of the reducer is the key value pairs, and which are divided into subparts which are called as a smaller set of tuples. The reducer task is always performed after the map job. Mostly after the map job, the reducer task is always performed. How MapReduce works? You can see here a large amount of informations are processed, when large amount of informations are processed, there are various phases available in the MapReduce works. Input phase, map phase, intermediate keys generation, combiner, shuffle and sort, reducer phase, output phase. These are some phases, important phases available in the MapReduce work. The input phase is the first phase, which gives some input to the mapper phase. In between the mapper phase and the reducer phase, in between the mapper phase and the combiner phase, sometimes combiner phase is the optional. There must be intermediate keys generated. What is the rule of the intermediate key? How a intermediate key generated? So you can use go through the network security for the identification of the intermediate key generator or compiler design. So map phase contains some information, process some information which is get from the input phase. Then intermediate keys are generated. If necessary, the keys are combined into some pods, and then the keys are shuffled or sorted according to the instruction given by the MapReduce method. According to the instruction given by the MapReduce method, the informations which are produced by the map phase is shuffle and sorting. Shuffle and sorting methods are utilized. After the shuffle and sorting methods, the shuffle and either shuffle or sorting, or either shuffle and sorting methods are necessary part in the MapReduce method. Then after the shuffle and sorting, the output is given to the reducer phase. Then finally the reducer phase reduces the input. As I already told, reducer task having only 5 task, but mapper task having 7 phases. So finally the output is created. This is the main simple execution flow of working flow of this MapReduce method. So what is input phase? Here we have a record reader. We must have a record reader. How we can read the stored information, that translate each record in an input file and sends the parsed data to the mapper in the form of key value pairs. In the form of key value pairs, the parsed data means clustered data, splitted data are given to the mapper phase. Then the mapper is a user defined function. Based on your requirements, you can define the user mapper function. It's a user defined function which takes a series of key value pairs and processes each one of them to generate 0 or more key value pairs. Mapper produces the key values which takes a series of key value pairs and processes each one separately and produces output. If necessary, the intermediate keys are created. The intermediate key, the key value pairs generated by the mapper are known as intermediate keys. The key values are actually generated. What is the work of the combiner? A combiner is a type of local reducer. It is a local reducer, a combiner. Sometimes it is optional. We cannot utilize it. If it is necessary, then we can use the combiner. Combining more than one output into a single output, which are produced by the mapper. This is the combiner, work of the combiner. So it takes the intermediate keys from the mapper as input and applies a user defined code to aggregate the values in a small scope of one mapper. So it is not part of the main MapReducer algorithm. It is an optional one. Already I told you. What is the work of the shuffle and sort? The reducer task starts with the shuffle and sort step. It downloads the grouped key value pairs onto the local machine. Then it should be shuffled. Shuffled means you can what? You can shuffle the information, the records, or sorting the information in ascending order or descending order. You can sort the information. Then reducer task takes the grouped key value paired data as input and runs a reducer function on each one of them. Each and every reducer function is actually MapReduce. Mapper function is actually executed by means of this reducer. Here the data can be aggregated, filtered, combined in a number of ways. So aggregated in the reducer function, the data which are produced by the mapper is aggregated, filtered and combined in a number of ways, and it requires a wide range of processing. Therefore, once the execution is over, it gives 0 or more key value pairs to the final step. What is the output phase? In the output phase, we have an output formatter that translates the final key value pairs from the reducer function and writes them onto a file using a record writer. The input of the mapper is the record writer information, and the output of the reducer is also a record writer information. This is the main work actually done by using this MapReduce works. What is the algorithm? Which the MapReduce algorithm implements various mathematical algorithms to divide a task into small parts. In order to split the large task into smaller task, we use various methods and assign them to multiple systems. In technical terms, MapReduce algorithm helps in sending the map and reduce task to appropriate server in a cluster. There are various mathematical algorithms which are used in the mapper function and mapper also in the reducer function: sorting, searching, indexing. You are all known very well what is the use of the sorting, what is the use of the searching, what is the use of the indexing. Already you are all studied in RDBMS subject itself, in data structure itself. Then what a special kind of method, MapReduce method available in MapReduce algorithm is TF-IDF. TF means time frequency and IDF means inverse document frequency. Time frequency and inverse document frequency mostly effectively utilized for the text analysis. For the text analysis nowadays we are used the semantic oriented text analysis concepts. Semantic analysis are the main form of the text analysis. In compiler design, you have some ideas about the semantic analysis and syntax analysis. Syntax is the checking of the overall step, the format of a particular reserved word. But semantics is the meaning of the checking of meaning of the word, meaning of the reserved word. What is the meaning of the reserved word is actually checked by using the semantics. Most of the text-oriented text processing methods are having this kind of time frequency and inverse document frequency. TF and IDF is a text processing algorithm. Nowadays in the world, in various repositories, what kind of data are mostly available means only text data. Number oriented data are very less. Text data are very large. Text data are available in the internet nowadays in the worldwide information. The text data are more available. So the text processing algorithm, which is short for time frequency, inverse document frequency, actually it is a text processing algorithm. It is one of the common web analysis algorithm. Here the term frequency refers to the number of times a term appears in a document. Suppose if you find a medical oriented text, in order to find a particular disease, for example diabetes, in a hospital data, in a medical oriented hospital data, you want to find out how many times the word diabetes appears in a particular database, which is done perfectly by using this time frequency and inverse document frequency algorithmic method, very effectively carried out. This TF and IDF method effectively processed effectively utilized in order to identify a frequency of word. How frequently a particular word is created and accessed, processed. Particular word is used and stored in a particular server. So what is term frequency now? It measures how frequently a particular term occurs in a document. In a particular document, how many times the term, a particular word is available. It is calculated by the number of times a word appears in a document. This term frequency calculates a number of times, how many number of times a particular word available in a particular text database, and by the total number of words in the document. How many total number of words are available in a particular document? So there must be a method TF equal to number of times the term the appears in a document, which divides total number of terms in the document. The total number of terms in the document in a particular text document, there are 1,000 text words are available. Number of words is number of terms in the document, in which the word the is available how many times? Only 110 times. 110 divided by 1,000 is the term frequency. Now, what is the inverse document frequency? It measures the importance of a term. It measures the importance of a term. What is the importance of a particular text, particular term, particular word? Term means word. It is calculated by the number of documents in the text database divided by the number of documents where a specific term appears. Now, for example, while computing TF, all the terms are considered equally important. But that means TF counts the term frequency for normal words like is, a, what, etc. These are all normal words. Thus, we need to know the frequency terms while scaling up the rare ones by the computing the following. D is the rare one. Inverse, by using this IDF algorithm, log of total number of documents divided by total number of documents with the term the, vice versa, that is inverse of the term frequency is the IDF. This, by using this method, we can calculate the IDF. Example of TF and IDF. Consider a document containing 1,000 words wherein the word hive appears 50 times. Therefore, the TF for hive is 50 divided by 1,000 equal to 0.05. Assume we have 10 million documents, the word hive appears in 1,000 of these. Then IDF is calculated as log of 10 million divided by 1,000 equal to 4. So TF IDF weight is the product of these quantities. 0.05 into 4 is equal to 0.20. Like we can find out the frequency of a particular word, the which is available. For example, if the database contains 10 million documents and in which the word hive contains 1,000 times, how we can understand the map and reduce task? Very simple. AB or CC or ACB, these are some input characters. We can split this input characters. ABR first, CCR second, splitting, ACB third, splitting. By using the map phase, you can note that A appears only one time, B appears only one time, R appears only one time. Here, you know that you can see here, C appears 2 times, C appears 1 time, C appears 1 time, R appears 1 time. A appears 1 time, C appears 1 time, B appears 1 time. Here, we can shuffle and sort A, B, C and then R. This is sorting. How we can shuffle? Here, there are 3 letters A, B, R. This A is going to this phase and this B is going to the second phase, R is going to this third phase. Shuffling method. In second phase, map phase, C1 is going to this one, C1 is going to this one, and R1 is going to this one. Okay. Now, how we can put this shuffle and sort means A, B, C, R is the sorting, ascending order, and how we can take 2A1 and 2B1, 3C1 in the first phase of the map and the second phase of the map and third phase of the map. A1 appears one time and another one time. One A1 and another one A1. 2 times A1 appears. B1 how many times appears? B1 one time and B1 another one time. B1 appears 2 times. C1 appears how many times? 3 times. R1 appears how many times? 2 times. Now, after the shuffle and sort method phase, it should be going to the reduce phase. How these are reduced? A appears 2 times, B appears 2 times, C appears 3 times, R appears 2 times. What, sir? This is the reduced phase. What, sir? We can easily find out this. Directly we can able to write this A2, B2, C3, R2 by referring this input characters. A 2 times appear, B 2 times appear, C 3 times appear, and R 2 times appear. Why we require this kind of map and reduce, split map phase, shuffle phase, these 3 phases why we require? Directly we can write by referring this input characters, and we can able to write the reduce phase directly. Why it is not possible, sir? Here only 3 characters, that is 4 characters and 3 lines are totally 9 characters or 9 words are available. Suppose if it is a 10 million characters, is it possible to easily find out by means of manual identification? It's not possible. 10 million characters are available means, which is not easy to identify individually how many times the letter A appears, how many times the letter B appears, how many times the letter C appears, and go like that. For that purpose, so this method is totally utilized for the analysis of the large volumes of data. 10 million data are available in the input phase. It is not easy to identify how many times a word or how many times a term, how many times a phrase appears, how many times a sentence appears. By means of ordinary identification, manual identification. Therefore, we require this kind of map and reduce method. Okay. So, MapReduce example. Let us take a real world example to comprehend the power of the MapReduce. Twitter receives around 500 million tweets per day. You have to assume Twitter receives 500 million tweets per day. A single day, 500 million. 1 million is how many? 10 lakhs. 1 million is 10 lakhs. So 500 million tweets per day a Twitter receives, which is nearly 3000 tweets per second. So per second 3000 tweets are accepted. The following illustration shows how Twitter manages its tweets with the help of the MapReduce. So input is the Twitter data, tweets. The Twitter data are utilized in 4 tasks: tokenize task, filter task, count task, aggregate counters task. There are 4 tasks are actually carried out in MapReduce. These 4 tasks are important task which is effectively utilized in MapReduce method. After applying the input information in these 4 tasks, then the data source adapter is actually Hadoop related databases are created. So this is one of the real life example of how we can effectively utilize the MapReduce example. Here, what is the work of the tokenize? Tokenizes the tokenize phase, tokenize task, tokenizes the tweets into maps of tokens and writes them as key value pairs. What is tokens? If you are very well about the compiler design, you can have idea about the token. In C language itself, The first little bit information discussed about the C language is tokens. A sequence of characters separated by comma or white spaces or special symbols or keywords is the token. Is constitutes a token. Sequence of characters which are separated by commas and special characters and some kind of information, some kind of other operator symbols, other kinds, some kind of operators are actually formed the tokens. Tokens are sequence of characters. So tokens are actually identified as a key value pairs. Then filters are utilized filtering the unwanted words from the maps of tokens. Sometimes the word the appears more than once. Only one time the word the taken into account. Writes the filtered maps as key value pairs. Then count generates a token counter per word. How many times that word appears. So to count is the task, one of the tasks which counts the number of tokens, the token counter per word. How many times the word, yes, a single token is appears. Aggregate counters prepares an aggregate of similar counter values into small manageable units. So this is the simple example of the MapReduce method. Now what is the use of this? What is the use of this terminology of MapReducer method? There are various terminologies of effectively utilized. Already we discussed about the name node, data node, master node, slave node, job tracker, task tracker. What is job? What is task? What is task attempt? So what is payload? The applications implement the map and the reduce functions and form the core of the job is the payload. Applications implement the map and reduce functions are payload. Mapper maps the input key value pairs to a set of intermediate key value pairs. Name node that manages the Hadoop distributed file system. Data node where data is presented in advance before any processing takes place. Master node where job tracker runs and which accepts job. Slave node where map and reduce programs runs in the slave node. Job tracker schedules jobs and tracks the assigned jobs to the task tracker. Already I told. Task tracker done the jobs which are produced inspected by the job tracker. Job is a program is an execution of a mapper and a reducer across a data set. A task is an execution of a mapper or a reducer on a slice of data. Task attempt is a particular instance of an attempt to execute a task on a slave node. This is the various terminologies used in the MapReduce method. Okay. Now, how the map reducer organizes? Already we told map task and reduce task. Job tracker and task tracker. What is the work of the map task and reduce task? We know that very well. What is the work of the job tracker, which act like a master? Task tracker act like a slaves, each of them performing on the jobs. So for every job submitted for execution in the system, in the MapReduce system, there is one job tracker that resides on name node, and there are multiple task trackers which resides on data node. Data node contains multiple task tracker, name node contains only one task tracker, in vice versa and vice versa. Job tracker contains only one name node, task tracker contains more than one data node. So execution control of this system is job is being submitted by a client. Job tracker carries it into several task tracker. The several task tracker, there are 3 task tracker, only one job tracker available. This job tracker contains only one name node, but the task tracker contains many data node. The task tracker have map task and reduce task in each and every phase, each and every data nodes. In each and every data node, there must be map task and reduce task is carried out. This is the simple example control, execution control of a system. A job is divided into multiple tasks which are then run on multiple data nodes in a cluster. It is the responsibility of job tracker to coordinate the activity by scheduling the task to run on different data nodes. Already we discussed what is the work of this job tracker and task tracker. Execution of individual task is done to look after by task tracker, which resides on every data node executing part of the job. Now the task tracker have the responsibility and which is to send the progress report to the job tracker. Already so in addition, task tracker periodically sends heartbeat signal. There must be a signal produced by the task tracker whether the task is over, completed or not, to the job tracker. So this job tracker keeps track of the overall progress of each job. In the event of task failure, it should be some tasks are not perfectly done by the task tracker. Some jobs are failed. Therefore, it should be noted by the job tracker. Okay, this is in this manner the execution is in execution control in MapReduce is actually carried out. How MapReduce works? We will discuss a simple example. The whole process goes to 4 phases of a map, namely execution, namely splitting, mapping, stuffing, and reducing. Already we discussed it. Consider the following 4 MapReduce programs. Welcome to Hadoop class. Hadoop is good. Hadoop is bad. These 3 sentences you have to consider. Here, welcome to Hadoop class. Hadoop is good. Hadoop is bad. This is the input. Welcome to Hadoop. Class Hadoop is good. Hadoop is bad. We can split the entire input into 4 phases, in which how many times the word welcome appears one time, to appears one time, Hadoop appears one time, class appears one time, Hadoop appears one time, is appears one time, and go like that. Then we can shuffle and sort B, C, D, E, F, G, H, I, J, K, L, M. So this is the shuffle and sort method. Welcome where appears. Okay, welcome appears where welcome only one time. Welcome appears one time. To appears one time. Hadoop appears one time. So class appears one time. Hadoop appears one time. Is appears one time. So this is the shuffling method, in which bad contains only one time, class contains only one time, good contains only one time, Hadoop contains 3 times, is contains 2 times, 2 contains one time, welcome contains one time. The final output is bad one time, class one time, good one time, Hadoop through 2, 3 times, and go like this. In this way, the MapReduce architecture is executed. We are all clearly known how the Hadoop MapReduce Hadoop is actually carried out. By means of this example, you can very well understand, I hope. So bad appears one time, all these informations are actually produced as an output of the reduced task. So inputs, how these informations are processed. Already I have enough discussion about the input splits, how the input are carried out, how a mapping is carried out, how effectively the word and the frequency of a particular word is calculated, counted. Yeah, how effectively a word is identified, and how many number of times frequently appears a particular word. Everything is frequency of word, and the word welcome and the frequency of word is 1, and go like that. Okay, how the shuffling is carried out, everything is discussed already. How the reducing phase is carried out, we discussed enough. Okay, so detailed explanation of the architecture, how this architecture actually carried out. One map task is created for each splitter when they executes map function for each record in the splitter. So one map task is created for each splitter. It is always beneficial to have multiple splits because the time taken to process a, it is a time taken for processing. A split is small as compared to the time taken for processing of the whole input. Okay. However, it is also not desirable to have split too small in size. Size wise, how the informations are splitted. When we splitting the text, when we splitting the mapper functions, the splits are smaller. The processing is better to load balanced since we are processing the splits into parallel. Very easy. The smaller task, smaller splits are available, easy to process. For most jobs, it is better to make a split size equal to the size of the HDFS block. Based on the HDFS block, whether it is 64-bit MP or 32-bit MP or 128-bit MP, so based on the HDFS block, the architecture is actually carried out. Execution of map task results into writing output to a local disk on the respective nodes and not a HDFS system. So map task is stored in the local node. Already we discussed it. Reason for choosing local disks is to speed up the process. HDFS over the HDFS is to avoid the replication of, also speed up the process, also avoiding the replication, multiple stores of the information. Map output is intermediate output, which is processed by reduced task to produce the final output. Okay. Once the job is completed, the map output can be thrown away actually. So storing it in HDFS with the replication becomes overkill. So we can easily avoid the replication by using the local disk. In the event of node failure before the map output is consumed by the reduced task, the Hadoop reruns the map task and on one another node and recreates the map output. Actually, the reduced task does not work on the concept of local data locality. So which having an output of every map task is fed to the reduced task. Map output is transferred to the machine where the reduced task is running. This is the actual scenario available in the map and reduced task. On this machine, on your machine, the output is merged and then passed to the user-defined reduce function. So unlike the map output, reduce output is stored in HDFS. MapReduce is stored in maps output is stored in the local disk in a manner, but the output that is output of the reduced task is stored in the HDFS format. What is join in MapReduce? Already we have to combine the two outputs, larger data sets into some join operations. There are two kinds of large amount of data sets are joined into single data sets by using the MapReduce join method. There are two kinds of join operations are carried out. These join operations are actually done by using the distributed manner. Once it is distributed, either mapper or reducer uses the smaller data set to perform a lookup for matching records from the large data sets and combine those records to form output records. There are two join operations actually done, map side join and reduced join. What is map side join and reduced side join? We can easily carry it out. There are some API informations or application process interface is carried out in MapReduce classes, and their methods that are involved in the operations of MapReduce are as follows. In API, there are some tasks in the join operations are carried out. One is job context interface, job classes, mapper class, reducer class. What is this simple concept? We can easily find out the tutorial for all this job and reduced dark. Already I told you tutorialspoint.com. Tutorialspoint.com is the website which is having a elaborate discussion about the mapper and reducer task. There are 4 API scores. There are 4 API informations are available. We will take a close look at the classes and their methods are involved in the operations of MapReduce programming. These are the 4 operations effectively utilized in API MapReduce. All these operations are clearly explained in this method. We can very well discuss, we can very well go to this, visit this site and perfectly identify what is the use of this map job context interface operation, job class operation. We have to write a source code for all these operations. We can utilize constructors and destructors in like in C++ functions and Java oriented functions in mapper and reducer. There are various methods utilized. User defined methods are available in order to utilize the job class in mapper and reducer task. Job, get job name, get job state. There are various methods. Then mapper class having a source, reducer class having a method, shuffle, sort, reducer, everything is available. So in a simple manner, we can easily identify what is the functioning of this MapReduce API. How we can partition the text input data by using the MapReduce partition. What is the role of the partitioner which is available in MapReduce? A partitioner works like a condition in processing and in an input data set. The partition phase takes place after the map phase before the reduce phase. The number of partitioners is equal to the number of reducers. That means a partitioner will divide the data according to the number of reducers. Therefore, the data passed from a single partitioner is processed by a single reducer. A partitioner partitions the key value pairs of intermediate map outputs. So it partitions the data using user-defined condition, which works like a hash function. Actually, the input of the MapReduce mapper function input text is to be partitioned into several kinds of clusters, which is called as partitioner, done by the partitioner. We have some special kind of operations are available in the partitioner. How we can effectively utilize the combiner? After the partitioner, we can utilize the combiner, combining all this information which are produced, a smaller kind of partitions, we can combine all this information by means of this MapReduce combiners, which is also semi-reducer. An optional class is used. Sometimes the combiner is not utilized. This main function, the main function of a combiner is to summarize the map output records with the same key. The output of a combiner will be sent to the network, to the actual reducer task as input. The output of the combiner is the input of the reducer task. The combiner class is used in between map class and the reducer task. Already I told. So usually the output of the map task is large, and the data transferred to the reducer task is very high. Okay. Then now we discuss about types of input format in MapReduce. There are various kinds of types. Input types are available: file input format, text input format, key value text input format, sequential file input format, sequence file as text input format, natural language oriented N line input, natural line input format, sequence file as a binary input format, database input format. These are some kind of information given to the input as an input to the MapReduce method. Suppose if you want to read more about unit test, how we have unit test is given in the method. Unit test using MRUnit. This is one of the very famous technology. That is example of unit. One of the unit is tested. One of the MapReducer function is tested by using this. You can visit this website. Unit testing Hadoop MapReduce jobs with the MRUnit, Makito, and PowerMock. These are some example real-time examples given in this. How this Hadoop MapReduce jobs have a unique code architecture that follows a specific template with which having the unit test. Everything is carried out. So example is given how to conduct the unit test, how to write the unit test. The source code is given by utilizing the MRUnit, a company based information extraction, how we can breaking the informations, what are the technologies, how we can write source code, everything is discussed in this method, how we can able to write the source code and everything, very simple manner. So you can visit this website, very simple. You can visit this website for the real life example of unit test by using the MRUnit. So how we can install the MapReduce function? We can install by using this tutorialspoint.com. If you go through this website, how we can install the MapReduce function, clearly they explained by means of simple steps. Suppose if you want to read out all this information that we discussed throughout this very simple manner, you can go to the quick guide in the tutorialspoint.com quick guide, and there are various useful websites are given into this. Okay, the quick guide is, if you go to this quick guide, we can easily understand what is MapReduce function, how we can able to process, what are the informations available, what is shuffling, what is sorting, indexing, TF, IDF, everything is clearly given by means of writing source code. We can have some simple information, simple source coding, how to install, how to verify, everything is given in this website. What are the functions available, what are the mapping information, how a table is reduced, MapReduce implementation, how a table is reduced by means of this MapReduce, how we can able to write source code, all are Java oriented source code, the packages, how we can able to write, everything is given in this MapReduce tutorial. Some simple useful references are also given. Now we are coming into the point of conclusion or summary of this MapReduce function. Therefore, MapReduce is a programming model for writing applications that can process big data in parallel on multiple nodes. MapReduce produces analytical capabilities for analyzing huge volumes of complex data. MapReduce is a programming paradigm that runs in a background of Hadoop to provide scalability and easy data processing solutions. Within this small introduction about the MapReduce, I will conclude. If you have any questions, you can read out my, you can spot, put your questions in the comment box. I will answer one by one once again. Before that, suppose if you want to know more about my sessions, other topics, MapReduce, Hive, Big Latin, and other kind of NoSQL databases, Hadoop introduction, you have to visit my YouTube channel, subscribe my YouTube channel. In the YouTube search bar, just type Dr. T. Velmurugan. You can very well visit to my YouTube channel. You can identify very well easily many concepts which are research oriented as well as Hadoop oriented as well as big data oriented. Okay, thank you very much for patiently listening my words. Okay, now if you have any questions, you can ask.
No. No, sir, there is no question. There is no question, sir.
No questions actually. Okay, yes, press the feedback form. Feedback form kurtacha?
Yes, sir.
Okay, there is no questions means thank you very much for silently listening my words. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. End போட்டுடலாமா?
Yes,
broadcast.
Yes, sir.
Feedback form மட்டும் திருப்பி போட்டுருங்க.